Now, as we continue on to section 3, it's another look at linear graphs. We'll be talking about graphing horizontal lines and vertical lines, graphing using the technique of intercepts, that would be the x and y intercept, and then parallel lines and perpendicular lines, and then recognizing whether something is in fact a linear equation as to oppose not a linear equation. Okay, so to continue what we started on the previous section, we'd like to review these formula that we will be covering in this chapter. So again, number 1, standard form of the linear equation in two variables, x and y. So this is standard form. Equation 2, slope-intercept. Remember, m is the slope and b is the y-intercept, so slope-intercept form. 3 is the formula for slope. 4 we're going to use actually in the next section. This is called the point slope form, where you have one point, a y sub 1 and an x sub 1, and you have your slope. So with that, you can actually generate an equation. Now 5 and 6 we mentioned, but we hadn't talked about them yet. They will be mentioned in this section. These are the formulas for a horizontal line and a vertical line. Now I have a little graph next to them. Y equals b. Well, you remember b up here is our y-intercept. So when you have an equation y equals, let's say, 6, 6 is the y-intercept. It's where this equation, which is a horizontal line, will cross at point B, which is 6, the y-axis. Oh, we had a little phone call coming in. All right, back to our work. Again, y equals b is the generalized formula for the horizontal line. Y equals 6. 6 is the y-intercept. It would be a horizontal line going through point B, which is 6. In formula 6, this is x equals a. Well, this is the vertical line formula, where we said a of the ordered pair was our x element, and you will have a vertical line going through point A. This could be a -3, let's say. X equals -3 would be a vertical line like this. Now I added a couple of other things. The slope of a horizontal line, which is m, equals 0. The slope of a vertical line, since when we do it, we would get something like -3 divided by 0. 0 would be in the denominator. Anytime you have 0 in the denominator, the results, we say, is undefined. So the slope of all vertical lines is undefined because the denominator would be 0. Okay, well, we have a few matching. So with that in mind, let me give you a moment. We'll pause the tape and you could see how you do. So we actually went over a number of these. The horizontal line formula is E. Parallel lines, we haven't done that yet, but you could imagine that if the graph look like this, what could you say about the slope? Well, the slopes are the same. Perpendicular lines, and we'll be going over that as we go through the lesson, or we've done it, depending when you view this, is if we have the slope of one is, let's say, 1/2, and the slope of the other line is a -2 over 1, and you were to multiply these slopes, the product of that is a -1. And you'll notice as you look at these, one is sort of the reciprocal of the other, but it's the negative reciprocal. So I sometimes add the rule that if m sub 1 times m sub 2, that is, if you multiply the slopes and the product is -1, then the lines are perpendicular. Standard form we've covered already. We call that formula 1. Remember, this one is formula 6, and this is formula 5. Now, hopefully you've written these on a little index card somewhere, and you're reviewing them as you try to memorize them. And then we said that something is undefined if as we describe the slope of a vertical line, and we have that up here. The slope of a vertical line is undefined. And the formula for the vertical line is formula 6, which is letter D. Now, for these next few, they're asking us to find the slope. And if it's undefined, so state. Well, we had said solve for y. So y equals, transpose that 2. In fact, let's do all of these. Solve for x. Now again, we want a positive x. So I'm going to transpose the x, transpose this, and that becomes that. Now here, notice when we solve for, let's say, whatever, the y's actually subtract out. So we end up with x equals -9. And here we have a negative y on the left, so I'm going to move it to the right to make it positive, and then transpose that. That makes it a -18, and that'll give me then a -11 that I'm going to divide by 2. So I end up here as y equals -11/2. Okay, now in these 4 cases, we have solved or attempted to solve for the letter y. Now we can figure out what's the slope. Well, here, this is equation 5. Y equals b. So the slope is 0. Here, this is equation 6. X equals a. So the slope is undefined. Here we have another x. So this is undefined. Again, this is x equals a. And this is y equals b. The slope is 0. Now, knowing what we know, this is a y equals -2. This is formula 5, horizontal line going through -2. So there's our graph. Here is x equals 4. This is formula 6, a vertical line, x equals 4, so a vertical line going through 4. Now remember, in something like this, we don't have x equals something, so we have to solve for x. So we're going to divide both sides by 5, and we get x equals -2. So we get our line, and there's our graph. Again, there are arrows at the end, and they go on to infinity. Number 14 is a little bit tricky. Notice we have the 3 times this function. Remember, we can put the function symbol as a y, and then we will add 5x to both sides. The x's cancel out, so we end up with this. And now we have to divide both sides by 3. We get y equals 3. Again, that's formula 5. That's a horizontal line going through 3. And remember, the slope of that is 0. Now in this next part, we're asked to find the intercepts. Well, I'm going to suggest that you use a new kind of t-chart. It's similar to what we've been doing, but I give this t-chart a special name. I call it the X and Y intercept t-chart. Why is that? Well, because when x is 0, whatever we find for y will be our y-intercept. And whenever y is 0, whatever we find for a is our x-intercept. So let's use this one to do this. So here, this is in Formula 1, standard form. Trying to put a 1 over here. Let's see if I can get it done here. 1. There we go. Formula 1, standard form. So x is 0. Forget about this now. We're going to divide both sides by a -1. We get y equals -2. Or just cover this up and then reverse the signs. Now if y is 0, x is 2. Now over here, this is in Formula 2 form, that is slope-intercept. But the best way to use this t-chart is if it's in standard form. So I'm going to put the x back over to the other side. I just transposed the 3x to the other side to put it in standard form. Then when it's in standard form, it's very easy to use this chart. So if x is 0, then this becomes 0. Y is going to be -6. Now if y is 0, right here, this is 0. We're going to divide both sides by a -3. That gives me a 2 here. So now I have my x and y intercepts. This is how they want you to solve this. So what do? Well, we plot them. 0, -2. So 0, -2 is right there. 2, 0 is right there. Get our line. And remember, it extends the full length of the graph there. There's that one. And now the other. 0, -6. 0, -6. Oh, I ran out of room. I don't have any room for that one. So let's just do it over here. I'll make a new graph here. So 0, -6 will be right about there. That's -6. That'll be that. And then 2, 0. It's right about there. And then this will be my graph. So, again, I ran out of room to do it there, but that's what it looks like. So let's take a look at something here before we go on. If I can get my pen back here. There we go. Now, right here, that is my y-intercept right there. It's where the line crosses the y-axis. And here, this is my x-intercept. And the same thing here, my x-intercept there, and my y-intercept there. So with 2 points, you can define a line. And by using this special t-chart, you can actually get the 2 intercepts. Okay, let's try some more. Now I did some preliminary work on 17 and 18, but here this is Formula 1, standard form. I've set up my x and y intercept t-chart. So if x is 0, this is going to be 2. Just divide both sides by a -5. And if y is 0, this is going to be a -5. So again, this is your y-intercept, and this is your x-intercept. And here this was in Formula 2 form, slope-intercept. So I move the positive 2x to the other side. So now it's in standard form. And if x is 0, y is 1. And if y is 0, now this is a little tricky. This is going to be a -1/2. Or you can think of it as -0.5. That would be okay too. So when you go to graph this now, 0, 2, it's right there. And -5, 0. -5, 0 is right there. And this one's going to be 0, 1. And a -1/2 is right there, halfway between 0 and -1. And we take our line now. And that's that one. And this one could be a little tricky, but let's see if we get it good here. And then extend it down this way too. There we go. Okay, on this page, there's a lot going on, and we've skipped a few that are not in our curriculum. You don't have to use a graphing calculator for examples 19 and 20, but going back to those original equations that we posted, I'm now going to add number 7, which is m sub 1 equals m sub 2, but b sub 1 does not equal b sub 2. So here we're saying the slopes are the same, but the y-intercepts are different. So if you were to graph that, as I did a little bit for you before, oh, that's not too great, but here we can see the slopes are the same, lousy diagram, but the y-intercepts are different. These lines are parallel, and that's the symbol for being parallel. So again, a good formula to add. And then for number 8, this formula is m sub 1, which is one slope. And if you multiply it by m sub 2, which is the other slope, and the product of that is a negative 1, then these lines are perpendicular. And this is the symbol upside down T for perpendicular. So in numbers 21 and 22, they're asking, without graphing, tell whether the graphs of each pair of equations are parallel. Well, how do you do that? What would be the strategy for doing that? And the answer is you solve for y. Put them in formula number 2 form, which is slope-intercept. Now, what do? Well, you just, I hit the wrong button there. Well, wait a minute. Yes, on that last one, I hit the wrong button. But again, you solve for the letter y. Put it in form 2. So now you can compare the slopes. Now, are they the same? No, so the lines are not parallel. Now, if you multiply these together, would you get a negative 1? No. So these aren't parallel, they're not perpendicular. So here they're just wondering if it's parallel. So the answer is no. But here, when we solve for a positive y, what I did is I moved that y and then I transposed that. And now we compare the slopes. There's a 1 by both. They are the same slopes, but different y-intercepts. So yes, that is parallel. Now, as we look at these two for number 23 and 24, we're wondering, does the product m sub 1 times m sub 2 equal a negative 1? Well, again, you have to find out what is the slope. So this is y. Our slope for that first equation is a 2. Then I solve for a positive y here. I get y is equal to a negative 1/2. So if I multiply 2 times a negative 1/2, that gives me a negative 1. So yes, this is parallel. Now again, they're putting this in standard form, but to compare the slope, you have to put it in slope-intercept form, which is what I've done here. And again, if you want to look at this more carefully, you can pause the tape and it'll just freeze on this slide. But otherwise, the tape gets super long. And again, we're going to compare the slope. This is a negative 1/3, and this one is a 1/3. Again, there's lots of stuff just getting this. So negative 1/3 times 1/3. Notice that's a negative 1/9. It's not a negative 1. So don't get faked out. These aren't even parallel because they're not the same slope. And the product of the slope doesn't give you a negative 1. So this is no. Okay, and we'll work on these in just a moment. So as we look at example 25, they want to find what is the slope of a line parallel to it. So you would put it in slope-intercept form, which is what this one is. So our slope that would be parallel would be a negative 3. And the one that would be perpendicular would be its negative reciprocal or opposite reciprocal, which is a positive 1/3. So this is the answer for A. This is the answer for B. Now in number 26, we see it's in form 1. We want to put it in form 2 by solving for y. So we transpose the negative 3x, it becomes a positive 3x. The 2's already there, we divide by 7. So this would be the slope of a line that's parallel to this. And then its negative reciprocal or opposite reciprocal would be this. So this is A, this is B. As we do number 27, they want us to write an equation that is parallel to this line, but has this y-intercept. So we're basically going to use formula 2, where we have the y equals, what will our slope that's parallel to this line be? Well, it's going to be a negative 2x. And the y-intercept, our new b up here, is going to be a negative 3. So that one was pretty easy. Now in number 4, this is in standard form, equation 1. We want to put it into slope-intercept form, which is equation 2. We solve for a positive y. So I transposed this, then divide and brought the 5 over as a negative 5, divided everything by 4, and then I wrote it this way. So my slope of the new equation will be the same, y equals 1/2 x. But now it's going to go through this b, this y-intercept, which is plus 1. Okay? Now we're going to do a similar thing for 29 and 30, but it's going to be perpendicular. So for these, again, we want to identify the slope. It's in formula 2 form. So 3 is our slope. So what would be the negative reciprocal of that? Negative 1/3 x, and then there's our y-intercept. Now here this is in standard form, so I have to solve for y. I'm dividing, I transpose the 2x, it became a negative 2x on this side, then divide everything by 3. So my parallel slope would be this. What would be the opposite reciprocal of this? Well, a positive 3/2, and there's our y-intercept right there. Now, let's take a look at 31 and 32. We want to determine if these equations are linear. Okay? And we want to find the slope of any non-vertical line. Well, again, what I want to do is I can look at these and see that there's no exponents on the x or y other than 1. So these are both linear. And I'll have to solve for y to put it in slope-intercept form to find the slope. All right, as we look at number 31, we had to solve for y here. And I'm showing you the steps. I transpose the y, and then eventually I find that our slope is 2/5. And here I cleared the parenthesis. Then I brought the y over to this side, the x over to that side, the negative 28 over to this side, divided everything by 3, and I get y equals a negative 7/3. So there's our slope. Okay. Now to wind up this section, which was quite challenging, we see in number 33 that in order to get this in slope-intercept form, we have to multiply both sides by 3. And here the 3's cancel out, and we get this. So that is linear. And the slope is a -3. Now, for number 34, now even though there's no exponents, having the x in the denominator makes it non-linear. So this is non-linear, and we can't determine the slope of that. Again, this is not really in our curriculum. Some of the stuff that's here is for a more advanced course, and we're using this book for later chapters in the Math 105, but they're expecting a lot. This is college algebra stuff, and we're going to stick more with the basics. Okay, well, good luck. We have one more section to do where we'll get to formula number 4, and then we'll have our test on chapter 2. Again, try to stay up to date because it gets challenging if you get behind.